The universe is an immense structure composed of countless diverse objects spread far apart in vast expanses of space. Even light can get lost in the depths between these objects. For instance, it takes over 4 years for a photon from the Sun to reach our closest star. Covering intergalactic distances takes millions of years. The realization that this enormous expanse is just a tiny part of the macrocosmos is truly astonishing. So, what are the actual dimensions of the universe? The forefront of outer space, the solar system, is merely one of the numerous planetary systems scattered throughout our galaxy. It consists of a single star in its main sequence stage and 8 planets with their moons. Additionally, our system includes over 1 million small celestial bodies like asteroids, comets, and meteoroids. Neptune, the furthest known planet in the solar system, has an orbital radius of approximately 30 astronomical units, equivalent to about 4 light hours. Surprisingly, Neptune's orbit encompasses only a small portion of the solar system. The most remote object discovered so far is the Far Route, located 132 or 18 light hours away from the Sun. However, even this object, barely visible against the vast backdrop of space, is still far from the hypothetical Oort cloud. The inner boundaries of the Oort cloud are approximately 2.0 away from the center of our system, while its outer boundaries extend at least 60.0, roughly equivalent to 1 light year. Beyond these limits lies interstellar space. Continuing further, we can observe more than 50 different types of stars within a radius from the Sun. These stars exhibit a wide range of characteristics, from dim and cold brown dwarfs to bright and well-known objects like Sirius, Procyon, and Altair. Some of these stars have their own planetary systems that may potentially harbor and support life. For example, Gliese 832c, located 16.1 light-years away from the Sun, bears the closest resemblance to Earth among all the known planets within the solar system. The average surface temperature on this exoplanet reaches 253 K, 20 C, and it completes a full orbit around its parent star in just 36 Earth days. Although the distance between us and Gliese 832c is relatively small in astronomical terms, a space probe traveling at a speed of approximately 17 km per second would take around 300 years to reach the vicinity of this exoplanet. Given our current technological capabilities, designing an interstellar spaceship capable of completing such a long journey is impossible. The solar system, along with its neighboring stars, is situated in the Orion Arm, which is part of the Milky Way galaxy. The Milky Way contains approximately 400 billion stars, and there may be over 1 trillion exoplanets of various kinds residing within it, according to current estimates. The main diameter of the Milky Way measures about 100 light years, and its stellar halo may be twice as large. While the main disk of the galaxy has a thickness of approximately 10 light years, it also features a distinct bulge in its center that spans roughly 30 light years. The Milky Way is part of a structure known as the Local Group, which comprises over 50 galaxies concentrated within a region measuring approximately 10 million light years in diameter. The largest members of the Local Group include the Andromeda Galaxy, the Triangulum Galaxy, and our own Milky Way. The cluster's total mass could potentially reach up to 3 trillion times that of the Sun, with our galaxy and Andromeda accounting for the majority of it. The Andromeda Galaxy, located around 2.5 million light-years away from Earth, is considered our closest galaxy, excluding smaller or dwarf galaxies. Moving up another level, the Local Group is part of the massive Virgo supercluster, consisting of over 30 galaxies. This supercluster occupies a space with a diameter of around 150 million light-years and has a total mass equivalent to approximately a quadrillion solar masses, which is approximately the mass of 10 Milky Way-sized galaxies. The supercluster possesses a flattened shape, with about 60 of its objects appearing like a thin sheet approximately 10 million light-years thick. Although this value may seem staggering, it is actually relatively small when compared to the large-scale structure of the universe. By zooming out even further, we can observe a giant supercluster of galaxies called Laniakea, which spans approximately 520 million light-years. Laniakea includes several galaxy superclusters, including the Virgo supercluster and the Great Attractor. The total mass of this formation amounts to approximately 100 quadrillion solar masses. The Great Attractor, positioned approximately 250 million light-years away from Earth, serves as the gravitational center for nearby objects. Unfortunately, it cannot be directly observed from Earth due to the obstructing plane of the Milky Way. Therefore, the nature of the Great Attractor remains a mystery. Laniakea is part of a large-scale structure of the universe, which consists of elaborate systems of galactic filaments, walls, and voids, vast empty regions in space. Some of these structures are incredibly massive. For instance, the Hercules Corona Borealis Great Wall extends over an astonishing distance of approximately 10 billion light-years. Since its discovery in 2013, this superstructure has been recognized as the largest component of the large-scale structure of the universe. It likely contains millions of galaxies, and the number of stars within it is virtually incalculable. The existence of such a structure remains a mystery to science, since the current theory of the universe's evolution suggests that such colossal clusters should not form. However, it is essential to note that this wall, though immense beyond human comprehension, represents just a tiny fraction of the observable universe. According to cosmological theories, space within the universe is continuously expanding, and the rate of expansion depends on the distance between objects. Objects that are farther away from an observer recede at a faster pace. This recession is not limited by the speed of light, since it is space itself that is expanding. Eventually, there will be a point where objects will be beyond each other's observable horizon.